Okay, so if you're doing this or if you're watching this video, you're probably really bored or you really like to do math problems, challenging math problems. This actually is from the math book that none of you have, um, but it's kind of an interesting problem. We're looking for an expression representing the space not occupied by the tennis balls. And all we really know is the general formulas for tennis ball, for the volume of a tennis ball. And we're going to assume that this is a perfect cylinder. It's not. It's tapered at the bottom, so it's not a perfect cylinder. But we're going to assume for this problem at least that it is. And so we need to find something that represents how much space is left inside, just in case we wanted to fill it with Jello or something. So think about that a little bit. I will give you the rest of the information that is given in the problem. It lets us know the volume of a tennis ball is 4/3 pi r cubed. And it lets us know that the volume of a cylinder is equal to pi r squared times h. Okay, so I mean, if you're doing this problem, I doubt that you find my videos entertaining enough to just watch this without actually wanting to figure out how to do it on your own. So maybe think about it, see if you could figure out something, and then I will go through this in steps, and maybe that will, if you're having a hard time getting started, maybe that'll get you started. Or if you just have no idea, or maybe you're just watching the video to watch the video. But you do need to pause it because I'm just going to keep going. I'm not going to stop. So go ahead and pause it if you'd like to try it, or if you'd like to just play around with the idea a little bit. Okay, so first of all, let's find what would be the volume of just the cylinder if it were empty. Pi r squared times h, and that really gets us nowhere. We know pi, we don't know h, and then we know r squared. Or could we figure out something for h? Well, we know that the volume of a tennis ball is pi r cubed. We know that r stands for the radius, and so what we know is that halfway across a tennis ball is r. And we have to go all the way across the tennis ball to get d, or diameter. And if we do that 3 times, then we actually end up going from the top of the cylinder to the bottom of the cylinder. And yes, this is not perfect. There is a tiny little bit of space above the top tennis ball. And this is not a perfect cylinder, but we're going to ignore those. And in the end, it would be a very minimal difference anyway. Okay, so we do actually know our height. Our height is, well, a diameter is 2r. So we actually have 1, 2, 3, 4, 5, 6 r's is our height. Our height is 6r. So our height is 6r. So then we can rewrite the volume of the cylinder as pi r squared times 6r. Okay, and if we simplify that, pi r squared times 6r, we can do that operation. That would give us 6 pi r cubed. Okay, 6 pi r cubed, that is the volume of our cylinder. Now, we need to know how much volume each of these tennis balls is taking up. And that's actually already given to us. It's 4/3 pi r cubed. But we have, that's per tennis ball though. So we have 3 of those. So we're going to multiply that by 3. So 3 times 4/3 pi r cubed. We know that if we multiply 3, we could write this as 3/1. When we multiply fractions, we multiply the top by the top, the bottom by the bottom. 3 times 4 is 12, divided by 3 is 4. We could also note that our denominator is 3. We're multiplying by 3. They cancel each other out. That doesn't mean they go away. It doesn't go to 0. It actually goes to 1. But we can get rid of the 3 in the denominator. So that leaves us with the total volume taken up by the tennis balls, the tennis ball total, VTT, is equal to 4 pi r cubed. And our volume of our cylinder is 6 pi r cubed. Nicely enough, we have the same units for both. We have 6 pi r cubed and 4 pi r cubed, so we can just subtract straight across. So 6 pi r cubed minus 4 pi r cubed. Okay, pi r cubed, this is just, it's the same number. Whatever it is, it's the same number. And so it's just like if we were to have x. We could say this is 6x minus 4x. And so the answer is going to be 2 pi r cubed. And so if we knew the radius of the tennis ball, which I suppose we could measure or something, if we knew the radius of the tennis ball, we could figure out how much open space is in the cylinder. And then we could find something else to put in there with it, I guess. We know how much air is in the cylinder with the tennis balls. Sort of. There's air inside the tennis balls too. Anyway, just kind of a fun problem, at least for me. Maybe you guys feel the same. If not, the more you do these, the more fun they get, actually. So do more of them. Okay, that'll do it for this video.